In the previous session, we have seen theory related to instantaneous center method to find out the velocities of different mechanisms. And here in this session, we will apply the same theory to solve different examples, most of the time previous gate examples. And before I take up these examples, here I would like to again recollect one point, that is, whenever you find out instantaneous center for two bodies, then at that instantaneous center, relative velocity of these two bodies equal to 0. That means absolute velocity of these two bodies are equal. So when two absolute velocities are equal and its relative velocity, that's the difference automatically becomes 0. We need to remember this point. We have already emphasized even in the previous session also, but again I would like to recollect. And this example is asked in 2014. Again, a link is given and two different points on these links also mentioned, and one of the point velocity is given, so that other point velocity needs to find out. This is very straightforward and a simple one. Let me recollect our concept. So if you want to find out instantaneous center of a body, how we find out? So we consider 2 points. We consider in each case 2 points, and we assume that we know linear velocity of those 2 points, such that intersection of the perpendicular to those two velocity vectors would give the instantaneous center of that particular link. So here also we apply the same theory. So here we have a VQ and its a direction, its a position is given, and we have a VP, its magnitude is not given but its direction is given. So we need to draw perpendicular to this VQ and VP, so that these two will meet at one point. That is the instantaneous center for this link. So let's draw that one. So this is the given link, and this is 20 degrees. It's making VP. This is a point P, and this is a point Q. VQ in this direction. So this is again horizontal. What is the angle? This is also 20 degrees. Why? Because we know that any line between two parallel lines, if it is making these two lines are parallel, this one is parallel to this one, these two horizontal are parallel, and if it is making angle theta with this horizontal, again in this direction, this same line will make angle theta. Here theta is 20 degrees, so here also it's making 20 degrees. So what is the instantaneous center? That is the intersection of the perpendiculars drawn to the two velocity vectors. So here one velocity vector is VP. So what is the perpendicular to that? So perpendicular to that is, this is the perpendicular, and another velocity vector is VQ. What is the perpendicular? This is the 45 degrees, and here this will make a perpendicular. Why? Because this is already 45 and this is already 45. So this is 90, and what is this angle? This is a 45 degrees. So this is the instantaneous center of the link PQ. Let me call it this point as R. So here we how to calculate VQ velocity VQ equal to omega of the link PQ into omega is the angular velocity of the link PQ into distance from the instantaneous center to the point Q, that is RQ. And again, what is the velocity of P? That equal to omega into distance from the instantaneous center to the point P into point P. So we need to find out RQ and RP. So this turn into a simple geometrical problem. So how to find out? This is 45 and 20 degrees. So what is this angle? Because total is 90 degrees minus 20, then it's a 70 degrees. Here already 65 degrees. So here angle becomes 45 degrees. And if you apply sine rule, means here, for example, if I write PQ by sine 45 degrees. Here this is the PQ and angle opposite to PQ is this one 45 degrees. Angle made at a point R, and again QR, this is the no, this is the side, and what is the opposite angle, that is the sine 70 degrees equal to PR by sine 65 degrees. So, but we need to find out VP. What is the VP? VP, if you divide these two equations, then this is VQ into omega get cancelled, then RP by RQ. But from this equation, we can write RP by RQ. This is the RP and this is the RQ. So what is the RP by RQ? If you take this star in this star, so what is the RP by RQ? That equal to sine 65 degrees by sine 70 degrees. That equal to, what is the value of VQ? So VQ is given as 1. So 1 into this value. This value, if you simplify and multiply with the 1, then you will get 0.96 meter per second. That is the velocity of the P. So this is the answer D. So what we have done, we used a simple theory, that is any link rotates about instantaneous center. So how to find out instantaneous center? That is a simply intersection of the perpendiculars drawn to the velocity vectors of a 2 points. This is our next question asked in 2016. Here length of the AB is given, that is a 1 meter, and this slide A is moving in the upward direction, so that slide B is moving in this direction, and at this configuration, at this instant, it's a physical configuration as you mentioned, and we need to find out, and velocity of VA at this instant is given, that is a VA equal to 2 meter per second, and velocity of midpoint of the rod. So let's consider this as the midpoint of the rod. This is for example E. Then we need to find out velocity of the E at this instant. So how to find out this one? So this is a double slider mechanism. So first let me redraw again this diagram. So this is, if I redraw the same mechanism, so let me consider this as a link 1. So fixed one is link 1, and this is also link 1, and this slider 2 and connecting aux 3, and again another slider as a link 4. So there are, what is the n value? N equal to 4, number of links are 4, and how many instantaneous centers should be there in this one? The n into n minus 1 by 2. So n into n minus 1 by 2, if you substitute n equal to 4, then you will get 6 instantaneous centers. So here let me identify instantaneous center. Here 3 4 instantaneous center, 3 4 at this point, instantaneous center 3 4 is at the point hinge joint, and at this point instantaneous center is 2 3. And what is the instantaneous center between link 1 and 2? That should be perpendicular to the slider that is sliding on the ground. So it can be anywhere else. It's not fixed actually. It's a varying along this plane, and but it's perpendicular to this one. And here also same case. So it could be anything, but perpendicular to this one. What is this one? This is a instantaneous center between ground 1 and slider 4, and this is the instantaneous center between ground 1 and slider 2. So so far we identified 4 instantaneous centers, and what are the remaining instantaneous center? So that is instantaneous center between 1 and 3 and instantaneous center between 2 and 4. So should we identify both the instantaneous center? Is that required? No, actually. So we need to find out only instantaneous center 1 3, because here link 3 is this one, and we need to calculate velocity on this link 3, that is at point A, E. This is point A and this is point B. This is A. We need to calculate E. So we are going to require only link 3. So what is the instantaneous center related to link 3, that we need to calculate. So how to calculate I13? So again we need to go back. So first of all we will take one set. So we will consider two sets, and first set is, what is the first set? So first set is links consist of 1, 2 and 3. So we already know instantaneous center 1 and 2 and instantaneous center 2 and 3. But so that instantaneous center between 1 and 3 should pass through these two instantaneous center. That is the Kennedy's theorem. So here this is the instantaneous center point A 2 3 and this is 1 3. So that the new instantaneous center 1 3 should be on the line passing through, going like this. So it should go through this point and perpendicular to this plane. And again what is the instant, and we consider one more set, that is 1 comma 4 comma 3. So we already know instantaneous center 1 4 and also instantaneous center 3 4, and instantaneous center between 1 and 3 is such a way that it should pass through this instantaneous center 3 and 4 and go like this. So it should, this is the instantaneous center 1 3. So let me redraw the same diagram. This is equilateral triangle. Here we are drawing some perpendicular here, and here we are drawing perpendicular to this side, that is, this is one line and this is another line. So these two are meeting at this position, and what is this angle 60, and this is also 60 because equilateral triangle, and this angle could be 30 because it's a perpendicular to this one. And what is this angle? Because this line is perpendicular to this side and this is a 60 degrees, so that this is a 30 degrees, and this is a point A and this is a point B, and let's consider midpoint. And in this triangle, and this is A and this is B, let's consider this as a C. And the triangle ABC, this is 30 and this is 30 and this is a 120 degrees. And if I draw a line joining midpoint E on AB with point C, then this is a perpendicular, because this is a isosceles triangle, and point joining opposite middle point of opposite side to the angle is divides, it's in the equal ratio, as well as it's perpendicular to this side. So this is 90 degrees, so that this is a 60 degrees and 60 degrees. So in this triangle AB, for example, if I consider AB equal to A, then AE equal to A by 2, and so at this instant, what is the C? C is instantaneous center 1 and 3. That means at this instant, body 1 and 3 are rotating about this point to C. So we know velocity at the point A, and we need to find out velocity at the point E. So what is the velocity at the point A? VA equal to omega 3. That means angular velocity of the link 3, this is link 3, we consider this as a link 3 or AB, into distance from the point A to the instantaneous center C, that is AC. And what is the velocity of E? Equal to angular velocity of link 3, that is nothing but angular velocity of the AB into distance CE. So distance from the instantaneous center of the link 3 to the point E. So we need to find out AC as well as CE, so that we can calculate velocity of the E. So in this triangle, ACE, what is the cos 30? Cos 30 equal to cos 30 degrees equal to AE by AC. So AC equal to AE by cos 30 degrees. What is AE? A by 2. So what is cos 30? Root 3 by 2. That means A by root 3. And tan 30 degrees equal to EC by AE. But we need EC. So EC equal to AE into tan 30 degrees. What is AE? A equal to A by 2, tan 30 equal to root 3. Sorry, 1 by root 3. So this becomes A by 2 root 3. And if I, from these two equations, I can write VE equal to VA into omega 3 get cancelled, VA into EC by AC. But EC by AC, from these equations, I can write EC by AC equal to A by 2. But what is A by 2 into VA? What is A? A equal to 1 meter. So 1 by 2 into what is VA? That is a 2 meter per second. So this is a 1 meter per second. So velocity of the VE equal to 1 meter per second. So let me recollect again. So here we need to find out velocity of this midpoint of the link. So how to, so here key is given like we need to find out velocity of point on this link. So we need to find out instantaneous center that consists of link 3. So that's why we have chosen, we need to identify instantaneous center I3 instead of 2, 4. So once it's identified, again it's simply instantaneous center distance into the angular velocity gives the linear velocity. This is a sliding tank mechanism. So let me first mark the links. This is link 1, this is link 2, 3 and 4. And we need to find out, it has given dimensions of different links, and is also given angular velocity of this link 2, omega 2 equal to 10 radian per second, and it's moving in a counterclockwise direction. And at this configuration, speed of the slider, so this slider speed has to be find out. That means V4, and this is going in this direction. So we already know here n equal to 4, that means how many instantaneous centers are there? 6 instantaneous center. So let's first identify instantaneous center. So between 1 and 2, this is 1 and 2, that's at the point O. For example, if this is a O and this considered as A, then instantaneous center 2, 3 is at the point A, hinge joint, and instantaneous center 3, 4 at point B. Let's say this point is B. And what is the instantaneous center between 1 and 4? So that is again, for a slider, it's a perpendicular and it's at infinity. We don't know about which point it's going on, but it's a perpendicular to the plane and that's infinity. This is I4. So we identified these 4. Then now we need to identify again 1, 3 and 2, 4. Instantaneous center 1, 3 and instantaneous center 2, 4. And sometimes you may get confusion whether this is instantaneous 1, 3 or 2, 4. So for that one, generally what we do is we make a polygon like this. Here 4 dots because of 4 links. Then this is 1, this is 2, this is 3 and this is 4. You join from point 1, you draw all possible lines that can join other points. So we have a 1, 3, we have instantaneous center from 1 to 2, 1 to 3 and from 1 to 4, and from 2 again you join all the points. So that is from 2 1, that is equivalent to 1 2, and from 2 to 3, and from 2 to 4, and from 4 you join again in the same direction or the same way. So again we have a 4 1, that's equivalent to 1 2 1 4, and we have 4 2, that is again equal to 2 4 and 4 3. So in this way we have 4 instantaneous centers. So that means here this, for example, or by simply saying this one, this diagonals, this is 3 and this is 4. So these diagonals 1 3 and 2 4 are not directly obtained, but instead we need to find out this instantaneous centers 1 3 and 2 4, diagonal instantaneous centers, by using Kennedy's theorem. So here again we need to find out I13 and I24 using Kennedy's theorem. But should we need to find out both the instantaneous center again? No, because here we need to find out instantaneous center of this linear velocity of this slider. That means the velocity of the slider at this point, that is on the slider as well as on the point 3. But we know already velocity of the point on a point at A, that is on the link 2, but the same point A also lies on the link 3. So that means we know velocity of the point on the link 3 at A. Then if you know that, we can find out velocity of the point B on the link 3, provided if you can find out the instantaneous center of the link 3. So we need to find out I13 here instead of I24. So how to find out I13 again? So let me redraw this diagram again. So how to find out I13? So we will take again two sets, that is 1 comma 2 comma 3, these 3 links. And what is the eye-center between 1 and 2? That is this one. And what is the eye-center between 2 and 3? So this is one. And eye-center between 1 and 3 should lie on line joining these two. So I will extend this line like this. So I13 should lie on this one. And another set is 1 comma 4 comma 3. So eye-center between 1 and 4 is perpendicular to this one, and eye-center between 3 and 4 is this point, so that this perpendicular should pass through this point according to the Kennedy's theorem. And these two lines are intersecting at this point here. So I will say this point as A and this point as B, so that this becomes C, and this is point O, and they have given this as a 90 degrees, and this length is 60, and this is a 240. And if I say this angle is theta, then this becomes 90 minus theta, because this is 90 degrees, and this is theta and this is 90 minus theta. This angle become theta because this is a perpendicular, so this is theta. And if this is 90, this is also 90, because this is just extension of this side and this is perpendicular to these two, and again this become 90 minus theta. So from this triangle, what is the value of theta? Theta equal to tan theta. Tan theta equal to 240 by 60 degrees. Sorry, 240 by 60. And theta will come approximately as a 75.964. 75.964 degrees. So let's keep that theta here. And here we know velocity. What is the velocity of A? Equal to, so this is the instantaneous center for the 1 and 3. So that means the bodies 1 and 3 at this instant are rotating about the instantaneous center I13. So here I will consider only body 3. So if I consider only body 3, that means that body is rotating about this instantaneous center 3. So what is the velocity of VA at this instant? So velocity of VA at this instant is omega 3 into distance AC. And what is the velocity B? Equal to again omega 3 into BC. So we need to find out AC and BC. So again we apply sine rule. So that is in the triangle ABC, AC by sine, this is AC, and the angle opposite to AC, that is a sine theta, equal to BC by angle opposite to side BC, this is 90 degrees, sine 90 degrees. And here what is the value of VB? VB equal to VA into BC by AC, that equal to, what is the BC by AC? 1 by sine theta. So VA by sine 75, sine 75.964 degrees, and VA is given as how we need to find out VA. So if you take link 2, what is the VA? VA on the link 2 equal to length of the link 2, that is 60 into omega. What is the omega? 10 radian per second. So this is a 600 mm per second, or this is 600 mm per second. So if you substitute these values here, you will get 618.465 meter per second. And here this is O2P is input link 4-bar mechanism. This is given as omega 2. For example, this is link 1, this is link 2, 3 and 4. So omega 2 is given as 2 radian per second in the counterclockwise direction, and angular velocity of the coupler PQ, we need to find out omega 3. So angular velocity of PQ, omega 3 has to be find out when the instant where this O4 O2 P equal to 180 degrees. So not at this instant, but instead we need to find out at this position. This is O2, this is O4, and P and Q. In this position we need to find out this angular velocity of PQ. So again same story. So we need to find out instantaneous centers first, and then we will select one particular instantaneous center so that we can find out omega 3. So again I will identify instantaneous center. This is instantaneous center 1 2, this is a 2 3, this is a 3 4, and this is a 1 4, and we remain with instantaneous center 1 3 and instantaneous center 2 4. So which instantaneous center we want? Again we need to find out omega 3. That means we need to find out, identify instantaneous center 1 3. So how to identify instantaneous center 1 3? Again we need to consider the link set consisting of the links 1 comma 2 comma 3. So that means this is a 1 2, this is a 2 3, so that 1 3 instantaneous center between 1 and 3 should lie on this line passing through 2 3 and 1 3. And if I take a set consisting of 1 comma 4 comma 3, again this instantaneous center 1 and 4, this is 1 and 4, and instantaneous center 3 and 4, this is 3 and 4, and that should, the instantaneous center having 1 and 3 should pass through the line this one, so that here these two lines are meeting at this point O4. So this is nothing but instantaneous center 1 3. So here in this case instantaneous center 1 3 and 1 4 coincident. So at this instant, what is the meaning of instantaneous center 1 and 3? At this instant, this at this instant these two bodies 1 and 3 are rotating about 1 and 3 and having a same absolute velocity, and here link 1 is constant, so that link 1 3 only link 3 is rotating about this one, and we can find out velocity of the point P from this, because this point is on the link 2 as well as 3. But how to find out velocity of point 3? Vp equal to given as omega 2 into PO2. But PO2, what is the PO2? That is A. PO2 equal to 2A. This is a meter per second. If I consider these are in the meters, these values in the meters, and this is the value of Vp, and if I consider this point is lying on the link 3, then what is the Vp? If I consider this point is lying on the link 3 with respect to this instantaneous center 1 and 3, so that is omega 3 into PO4. But what is the PO4? O2 to O4 distance is A and O2 to P distance is A. So that means PO4 equal to 2A. So this is not omega 2, omega 3. So omega 3 into 2A. But it's already equal to 2A. So that means if I equate this Vp, omega 3 equal to, so this 2 will get cancelled, A get cancelled, 1 radian per second. This is our next problem asked in 2004. This is very simple one, just to identify instantaneous centers. So figure below planar mechanism single degree of freedom. 2 and 4. We need to calculate 2 and 4. So this is a 1 fixed one, and this is a 2. This is a slider 2, 3 and 4, and again this is a 1. This is a double slider mechanism. So first of all we identify this is identify this one 1 2. This is a 1 2, and sorry this is a 2 3, and this is a instantaneous center 3 4, and what is the 1 2? Instantaneous center between 1 and 2. Again it's a slider and this is a ground, so instantaneous center should lie on a perpendicular, and this perpendicular we don't know in which point it's passing through, so it can be any point. So this instantaneous center 1 2 is on this line, and here also instantaneous center 1 and 4 is perpendicular to the ground, but it can be any perpendicular. So this is 1 4. Here we need to find out I 2 4. So this consists of two sets of links, that is a 1 comma 2 comma 4. So what is the instantaneous 2 and instantaneous center between 1 and 2? 1 and 2 is this one, and 1 and 4 is again this one, and we don't know at which point they are touching, because this is not a fixed one. It can move, it can be here also, it can be here also. In the same way this perpendicular can be here also, here also. So from this set we cannot find out. So take another set that consists of 3 comma 2 comma 4. So here we know instantaneous center 2 3 and instantaneous center 3 comma 4. This is a 3 comma 4. So that the instantaneous center 2 4 should lie on this line, should lie on this line, and if should lie on this line. So, and these lines we don't know, these lines can meet at any place. For example, if this line is 1 4, instantaneous center 1 4 is like this, and this is, and if this is like this, it can touch here. Or if it is like this, if 1 2 is like this, and if 1 4 is like this, instantaneous center, it can touch this point. So in the same way, there are infinity points. There are infinity points that instantaneous center, if these two I12 and I14 are touching on this line, that means it gives instantaneous center 2 4. Okay, so for infinity points, there are infinite number of possible options or positions that I24 can be formed. That means I24 is formed at infinity. So at infinity, there is no particular position where this I24 can be formed. So here in this case, infinity. And let's say extend the same problem and find out what could be the instantaneous center. What could be the instantaneous center for the I13? So I13. So two sets. What is that? 1 comma 2 comma 3. So instantaneous center between 1 and 2 is this one, and 2 and 3 is this one. So that this line should pass like this. And on the set is 1 comma 4 comma 3. So instantaneous center between 1 and 4 is this one, perpendicular, and instantaneous center between 3 and 4 is this point. So that this line again passes like this. This line passing through a fixed point, and this is also passing through a fixed point. So that these two are meeting at point N. So instantaneous center of I13 is at point N.